Hey Pre-Calc, we are coming back with 8.7 with graphs and analysis of log functions. And as you remind yourself as we move forward with this, we are reminded that the inverse of exponents are logs. So if we just remember some of the properties with exponents, we should and understand that they are one-to-one functions. That means they pass not only the vertical line test because they're functions, but the horizontal line test. And what we can then do to, okay, so that answers if it's one-to-one or not. But as far as an inverse goes, that's when we switch x and y. And then we solve for y. And I do realize that we write things in function notation, but f of x is the same thing as y. So what we have in front of us is already a few things that we've learned in the past, where we were able to graph the parent function of y equals 2 to the x. That's what this left chart was. That's what we did in the exponential function unit. And then we talked about how adding inside of the exponent shifts left 3. And then how we would reflect over the x-axis when the negative is in front, and then this plus 2 would shift up 2. So we could take each one of these values and plot the points. If you need to see the parent graph, of doing 2 to the negative second power is 1/4, and then 2 to the negative first power is 1/2, 2 to the 0 power equals 1, and I'm doing this in a faint color so you could then, oops, that should have been 2/4. And then you could actually see how that negative 2 was shifted left 3 to negative 5. And then when you negated the 1/4 and add 2 to it, you get this value. So negative 5, 1 3/4. Things like that. Now, I don't want to over-explain this, but you can work through and examine. And other bits and pieces, like talking about negative reflects over the x-axis, so we're below the horizontal asymptote. And the horizontal asymptote is at x equals, or sorry, I'm ready for the next, or what we're doing with logs, at y equals 2. Because when if we were to do this inverse of a function, we could numerically do it by actually taking those x and y values and switching them. X and y. And so maybe I'll do that in a purple color here. So if I were to do the inverse, I'll do the inverse down here in this graph. This is the bottom of the page if you're following along, page 499 if I use the same page as yours. But that 1 3/4 would be placed at as the x coordinate. So 1 3/4 down 5. And then 1 1/2. And then down 4. And then 1 negative 3. So right 1 down 3. 0 negative 2. Negative 2 negative 1. And then negative 6 0. And when we connect the dots, there's one more thing that you want to pay close attention to, so you might want to wait until I'm finished drawing this, is that clue that I just skipped over earlier, and it's talking about the horizontal asymptote. Well, remember, if we're switching x and y, well, that should make sense that the horizontal asymptote at y equals 2, and we switch it to be x equals, and I'll switch colors again, so it's x equals 2. Well, now if it's x equals, it must be a vertical asymptote. And that's what I was trying to convey on this problem, is that I have a vertical asymptote right here at x equals 2. And one more bit that I'll mention before moving on is, since the exponential function was below the horizontal asymptote, that means negative values would be below the horizontal asymptote. Well, we want negative values for the vertical asymptote here, so it would be to the left of the vertical asymptote. I think I've said everything I want to on that. So if we're given the equation on the next page of our notes. I kind of said this earlier where we switch x and y and then solve for y. If I wanted to, I could add a few steps in here, like remember f of x is the same thing as y equals, and then when we solve this y, we rewrite it as f inverse of x equals. So I guess I'm just assuming that you're well aware of that first and last step. So for instance, I'll go ahead and type in that first step of understanding that that's y equals negative 2 to the x plus 3 power, and then plus 2, and now we need to switch them. So x equals negative of 2 to the x plus 3 power plus 2. Now what I would do is try to get the exponent all by itself. I almost said exponential and then switched. So what I would do, this is just me, is I would think about how I can subtract 2 to the left side, but then I also need to divide everything by negative 1. I'll even change colors to emphasize that there's a negative 1 as an a value in front. So that's going to change the sign of everything. So divide everything by negative 1. So now we have 2 to the x plus 3 power. And my next step then is to get rid of that base. And for our purposes, and because our calculators will actually do it, it makes the most sense to write it as log base 2. And we've already learned that when the base and that number are the same, that they'll cancel each other out. Oh, whoops, I forgot to, typical Mr. Higbee. I forgot to change this to be y. I'm sure some of you were sitting there and thinking it. There we go. And then my last step to solve for y would be to subtract that 3 over. And while I'm at it, I might as well go ahead and change that to be written as f inverse. And sometimes what you'll see is a teacher will write that negative 3 in front, but so many students are used to seeing the shifting left or right or down in this case when the minus is the very last thing. But there is the equation, and what you should notice from this is if I asked you for the transformations from the base function of log base 2, so if you had a parent function, this is just sort of extra knowledge for you, log base 2 of x, and it has the ordered pair x, y, the transformation to this new function would be, if you remember, this is reflecting over the y-axis, and when you reflect over the y-axis, you still shift this direction, so right 2. And if you look at my y-coordinate, it has shifted down 3. So if I went back a slide, back to the previous page, and you were to look at the parent function of log, which we'll talk about, it is reflected over the y-axis, shifted right 2 and down 3, which we haven't looked at the parent function for log yet. So right now we're just practicing finding the inverse. So maybe I'll just do a couple, and hopefully I don't make the same mistake that I did before where I forgot to write this as negative y plus 3. But that's your first step, switch x and y. So because there's not a negative in front, all I have to do is add the 3 over. Notice that I like to put a space in here just because it makes sense to me to do log base 2 on both sides. I also like to put in parentheses, so I know that it's only the log base 2 of x plus 3, so that piece cancels. And then at this point, it actually might be advantageous, since we're left with negative y plus 3. It might actually work out for you if you just add y to the left side and subtract that log base 2 to the right side. And that plus 3 is still on the right side, so that would be your final answer. But again, I want you to practice writing that inverse notation. So why don't you try the next couple on your own. Hit pause. As I show you the answer key. Let's see, that was the first one. Notice that he explained it slightly different, where he left the negative y on the right side. But notice that the answer is the same, where the negative log base 2 is the same and plus 3, but addition's commutative, so you can switch the order around if you want. In case you forgot, because maybe it's been a few days, that you forgot that the common base, okay, so if you have e, to undo e is natural log. Maybe I'll walk you through this middle one, but go ahead and hit pause on the video and see if you can get the same answer on this right one. All right, and I'm going to switch back, and I'm going to actually work out the middle one. So in the middle one, switch x and y around. I would subtract 3 over first because you need the exponent by itself. Sometimes we say you isolate the exponent. To undo e, instead of writing log base e, we know to write natural log of e. And well, now it's y plus 2, so to me it makes perfect sense just to subtract 2 to the left side. You still have natural log of x minus 3 there, and just close your parenthesis. So as I would write this answer, I would just rewrite y as f inverse. There you go. So in the last couple minutes of this video, I do want to at least get you on the next slide and getting you to think a little bit, and maybe when I start the next video, I'll just, I don't know if I'll need to re-explain anything here. But anyway, for an exponential function, that's what we're answering, is for f, which is the exponential, is the domain is always all reals. Okay. Now the range, it depends on two things. Is there an x-axis reflection? So let me just write a question, because there's not on this one. So we're above the horizontal asymptote. And what is the horizontal asymptote? Well, actually it's asked for right here, so I might as well write it. Horizontal asymptote at y equals negative 3. So back to the range, if we're above the horizontal asymptote, then we want to go from negative 3 to infinity for our range. I think I've answered every question there. So to answer for the inverse, just remember that the inverse, the domain becomes the range, and the range becomes a domain. So it makes sense that if we're above the horizontal asymptote, we're going to be to the right of the vertical asymptote. And maybe I'll even jot down the note. The range becomes a domain, and the domain becomes the range. So therefore, the range is all reals, negative infinity to infinity. And the vertical asymptote will be at, well, y becomes x equals negative 3. Now I believe we just found the equation of the inverse on the previous page. I don't know if you noticed, these are the same equations, so you don't have to go through the same work. So my answer is negative log base 2 of x plus 3 plus 3. And the point is that you recognize that what happens when we set the argument equal to 0. We've done this before. If we set the argument equal to 0, we'll be able to get an answer of x equals negative 3. And what you should notice is that's the equation of the vertical asymptote. And one more thing is that we can only log positives. That's why we're doing this. We can only log positives. So if I set x plus 3, the argument greater than 0, we get x is greater than negative 3. And why am I asking you to do that? That is the equation of the domain that we found earlier. So in the last 30 seconds, I'll let you hit pause on the video, try some of these on your own, and you already know it. I'm going to jump to the answer key so I can jump right into the next piece, or I can start the next video explaining anything else I need to. Oh no. Sorry, I forgot to rotate my thing. So pause before the video ends.